Who wants me to do number 1? Off the sheet. Anyone for number 2 off the sheet? Number 3?
Yeah.
Right, okay. So 2t minus 1 to be squared minus 2t minus 1 minus 6 equals 0. Now, you can solve this, you can multiply this out, right, tidy it up and then factorize and solve if you want, right, or you can use substitution, right, okay, so this one's not too bad, as in, it's not too bad to multiply out, so you could multiply it out and gather it up and factorize your quadratic, okay, right, or I think what was it kind of implied was it was from the substitution section, so to use substitution, but it really doesn't matter. Once you get the right answer, it doesn't matter how you did it. So I'm going to let y equal 2t minus 1. So everywhere I see a 2t minus 1, I'm writing y. So this is y to be squared minus y minus 6 equals 0. Is that okay? 2 sets of brackets, factorize y and y, 3 and 2, a minus and a plus. So then let each bracket equal 0, y equals 3, and y equals minus 2. Now if you use substitution, you need to substitute back then. So 2t minus 1 is equal to 3, or 2t minus 1 is equal to minus 2. Okay, so solving here, we end up with 2t equals 4, so t is equal to 2. And here we'll end up with 2t is equal to minus 1, so t is equal to minus 1 over 2. Is that okay? Right, so I use the substitution method, but as I say, it's not too hard to multiply that out, tidy it up, make it quadratic and factorize. Okay? Questions? Nope. Right, that was number 3. Number 4?
Yeah.
Yeah, okay. Can I take this away? Right, okay, so number 4 is by completing the square, find the solution of, right, okay, so you could find the solution using the minus b formula. Now, if this was on the leave cert, they would just say solve. They wouldn't tell you how to solve, so they wouldn't say by completing the square. Okay, right? So you could use the minus b formula straight off, right? Okay, but we're practicing completing the square. So to complete the square, you take the first 2 terms and you write them down. Then you have the coefficient of x. So ignore the sign. Have 4 and you get 2. Square it, 4. So you add 4 and you subtract 4. So you get half the coefficient of x and you square it. And then you add it and subtract it. So you're not changing the equation, right? And then you have a minus 10 equals 0. So the plus 4, minus 4 there in the middle, you haven't changed the equation because they give you 0. Okay? Then if you factorize out of the first 2, it'll be x and x. It'll be 2 and 2, and it'll be a minus and a minus. Okay? Then minus 4 minus 10 is minus 14 equals 0. So that means x minus 2, 2b squared minus 14 equals 0. That's the square completed. So how you solve from completing the square is you move the number over, so you'll get x minus 2 to be squared is equal to 14. You get the square root of each side, so getting the square root of this side, you just get x minus 2. And over this side, you get the square root of 14. But remember, a square root can be plus or a minus, right? Okay, so that's where square root can be a plus or a minus. And then just bring over the 2. So x is equal to 2 plus or minus root 14, which is what you would have got if you used the minus b formula. Is that okay? It's shorter than the minus b formula though, isn't it? Yeah. Okay. 5, anyone? Yeah. Okay. Can I move? No. Can I move? Right, okay, so number 5. The roots of the equation x2, so here's the equation, 2ax plus b minus 4a squared equals 0. And it said the roots are equal. So that means b squared minus 4ac equals 0. That's what roots are equal mean. Right? So determinant is 0 if the roots are equal. Right? So b squared, b is a number in front of x. So b to be squared is minus 2a all to be squared. Now make sure you take the minus. I know it will cancel out when you square anyway, but just to have it fully correct. Right, b is minus 2a, it's not just 2a. Right, then I have to go minus 4. A is the number in front of x squared, which is 1. And c is a number with no x or x squared, so that's b minus 4a squared. And because they told me that is real, we know that equals to 0. So squaring this, square minus 2 you get 4, square a you get a squared. Here you're multiplying in by a minus 4. So minus 4 by b is minus 4b. And then minus by a minus is a plus. 4 by 4a squared is 16a squared. Okay, and you know it works out to be 0 because they told me the roots are equal. Right, 4a squared and 16a squared gives me 20a squared. Sorry, I forgot the b there, didn't I? Minus 4b. So that's 20a squared minus 4b equals 0. So express b in terms of a. So that means I want b equal to whatever all the a's are. So minus 4b is equal to minus 20a squared. Then divide each side by minus 4. And you'll end up with b is equal to 5a squared. Minus 20, minus divided by minus is a plus, 20 divided by 4 is 5. Are we good?
Yes.
6?
Yeah.
Right. Yeah, I will. I am recording it. Yes. There I go. Number 6. So, right. Solve the simultaneous equation. So this is one linear, one quadratic. How do you know which is the linear, which is the quadratic? The quadratic has the square term. So this is the linear, right? This is the quadratic because it has the square terms. Okay? You take the linear, you rearrange it so you have x equal to everything else or y equal to everything else. Right? What would be the best one to choose here, please? Y, x equals or y equals? Y equals, because if you choose x equals, what will happen? You'll end up with a fraction, which is possible to solve, right? Okay, of course it's possible to solve, but it's just harder, right? So I'm going to leave y on its own, and I'm going to bring over the 2x, so it's 8 minus 2x. So I chose the y because there's a 1 in front of the y. If I chose the x equals everything else, I would have ended up with a fraction, and I don't want to make my life harder, right? Come over here, everywhere I see a y, put in an 8 minus 2x, so it's x squared plus 8 minus 2x squared, all to be squared, equals 52. Okay, squaring out your brackets, so you have to square the first term, 64. Twice the first by the second, so a2s are 16 by 2 is 32. Square the last, plus 4x squared. While I'm on the move, I'll bring over the 52, make it a minus 52, so it all equals 0. Is that okay? Tidying it up, I have x squared and 4x squared gives me 5x squared. Put my x's together, I have minus 32x My numbers, I have plus 64 minus 52, which is plus 12 equals 0. Yeah? So then get your two sets of brackets or factorize or use the minus b formula, whatever suits you. You get 5x and x 4, no, that won't work. 6 and 2, a minus and a minus. So that would work. Minus 30x minus 2x is minus 32x. Yeah? Okay, so then you let each bracket equal 0. So 5x minus 2 equals 0. So that means x is equal to 2 over 5. And x minus 6 equals 0. And x is equal to 6. Right, so for each x you have to get a matching y. So you get your matching y by going back to the linear equation. So the linear equation told me that y was equal to 8 minus 2 times x. So when x is 2/5, y is equal to 8 minus 2 times 2/5. So that's 4/5, that's 5 4s, 5 8s, 40, take away 36 over 5, so y is equal to 36 over 5. Is that okay? And then when x is 6, y is equal to 8 minus 2 times 6. So that means y is equal to minus 4. Okay? So you have two sets of answers. X is 6, y is minus 4. Or x is 2/5, y is 36 over 5. Are we good? Okay, that was number 6. Push it up, yeah. Up. Sorry, what I'll do is this way. Okay, that was number 6. Number 7? 7. Do it? Okay. We good with this? People said writing? We're gone? Okay, so number 7, girls. Right, basically the roots of the equation are 4 minus 1/3. So that means the answer was 4 and the answer was minus 1/3. Okay, so that was originally x minus 4 equals 0. This one was originally x plus 1/3 equals 0. Sorry, we learnt the formula, didn't we? I don't need to do this, do I? Will I do it this way? I might as well finish it this way, seeing I did it this way. Right, so that's x minus 4 equals 0. Multiply everything by 3 or get a common denominator. So 3x plus 1 equals 0 and drop your common denominator. Is that okay? So your brackets were originally x minus 4 times 3x plus 1. Multiply it out and tidy it up, so that would be 3x squared minus 12x minus 11x minus 4 equals 0. Okay? Or we could use the formula. The formula is x squared minus x times the sum of the roots minus x times the sum of the roots so this is the shortcut plus the product. So x squared minus x times the sum of the roots plus the product of the roots equals 0. So x squared minus x times the sum of the roots are 4 minus 1/3, right? Plus the product of the roots is 4 multiplied by minus 1/3 equals 0. Okay, so that would be x squared. Right, 4 take away 1/3 would be 11 over 3. So that would be minus 11 over 3x. Is that okay? That's minus 11 over 3. No, that's plus 11 over 3. When I multiply it, it's minus 11 over 3x. Is that right? Plus the product of the roots, multiply on 4 over 3. Right, get rid of that fraction, get a common denominator. So 1 into 3 goes 3 times 3 multiplied by whatever is above the line. 3 into 3 goes once, multiplied by whatever is above the line. 3 into 3 goes once, multiplied by whatever is above the line, equals 0. Drop the common denominator because you have an equal sign, so you get 3x squared minus 11x minus 4 equals 0, which is what I got a minute ago. I hope it is, yes. Right? Yes.
Would you multiply the common denominator, or would you still get marks for leaving it as a fraction?
Would you still get marks? I think you nearly, I'd say you should get nearly all the marks, because it didn't say give it in its simplest form, or, do you know what I mean? So I think you'd get nearly all the marks, if not all the marks. It depends on the year. Some years they're trying to take marks off you, and some years they're trying to throw marks at you. Most years they try and throw marks at you though. So that's good to know, yeah? Okay, anything else? Right, for that one? Right, that was number 6. That was number 7 even. Number 8, am I doing 8? Sorry, leave up 7, the end of it. Is that one okay? Do you want the other board for 7? I have an itchy nose, that means I'm going to fight with someone. Be careful, lads. Right, okay, are we okay?
Yeah.
Is it down?
Yeah.
Are you sure? Going, gone? Right, number 8, so, right, is the square root of 2x minus 1 plus the square root of x minus 1 equals 5. Okay, so the rule is, if there's 2 square root signs, you put one on the left and one on the right. Okay, so I'll leave the square root of 2x minus 1. I'll leave the 5 here and bring over that, so that was a plus the square root of x minus 1, now it's a minus. Okay? So that's the rule. If there's 2 square roots, you put a square root on both sides. Okay, so then you square each side. So square and square. Okay? So squaring this side, the square root and the square just cancel each other out, so I'm just left with 2x minus 1. Over this side now, right, you have to square the first, twice the first by the second, square the last. So square the first, you get 25. Twice the first is 10, multiplied by the last is 10 square root of x minus 1. And then when you square the last term, that becomes a plus, and the square root and the square just cancel each other out, so that's x minus 1. Okay? Are we okay with that? Right? So now there's still a square root sign. So what I need to do is I need to leave that on its own at one side, and I need to have everything else over on the other side and tidy it up. Okay, so I have a 2x minus 1 here. I'm going to bring over that 25. I'm going to bring over that plus x, and I'm going to bring over that minus 1. Right, okay, equals, and that will just leave me with a minus 10 times the square root of x minus 1. Great. Right, tidying up here, I'll get x minus 25, yeah, equals minus 10 times the square root of x minus 1. So I still have a square root sign. So what do I need to do now? Square both sides again. So you're squaring this side, and you're squaring this side. Squaring this side, square the first, twice the first by the second is 50x, square the last is plus 625. Okay, over here, square 10, you'll get 100. Actually, square minus 10 and you'll get plus 100. And then square x minus, the square root of x minus 1 to be squared just becomes x minus 1. Is that alright? Yes?
You see in the third line, how did you get the...
1, 2, 3 here.
Just the minus 10 and then the...
So, square the first term, twice, it's a set of brackets to be squared, so square the first, twice the first by the second, so 2 times 5 is 10, 10 multiplied by the square root of x minus 1 is just 10 root x minus 1, is that okay? And then square the last, okay, because it's a bracket to be squared. Are we good? Right, okay. Right, so that would be x squared minus 50x plus 625, multiplying in here, you have 100x minus 100. Okay, so that would be x squared minus 150x minus 725 equals 0. Yeah? Okay, you'll have to help me with the factors for this now because I'm not going at my calculator there. So x and x, it's probably 25 and something is, no it's not. Does anyone know the factors of 7? Have I made a mistake first? Say that again? It's plus 725, yeah, thank you. That would be a minus and a minus. 75 by 75, what would that be? No, too much.
I mean, it's divisible by 25 and it
So-
goes 29 times 4.
No, that wouldn't work. Does anyone have this finished? 145 and 5, thank you. Yeah. I'd be stubborn and I'd stick with my calculator and I'd start dividing it by lots of numbers. Okay, but probably, you know, if you're not confident about getting the factors, the minus b formula is the way to go. Yeah. Right, are we good? So x is equal to 145 or x is equal to 5. Okay, and then go back up to the top, girls, just to make sure, right, okay, that it's when you fill in for the x, that you don't get the square root of a negative number, right? So if you go back up to the top here, I'll be getting the square root of 289, which is fine. Here I'll be getting, when x is 145, that's the square root of 144, that's fine. When x is 5, this is square root of 9, which is fine. And when x is 5, that's the square root of 4, which is also fine. So they're both valid answers, okay? So just have a quick look, because sometimes one of the, if you fill back in for the x, it'll be the square root of a negative number, so that means the answer doesn't exist. Yes?
Can you push the square forward up a bit?
Yeah.
So are we only checking for if it's a negative or if it's
Yeah.
a square number?
Yeah, no, it doesn't have to be a perfect square, so it can be the square root of 13, we don't care, as long as it's the square root of a positive number. Right, are we good?
Do you know what, if you have something like that, how do you know like when to bring it over? Like that's the
How you know when to bring what over?
like, do you know the way you said when you have two square roots, you bring one of them across?
Yeah, that's the rule, one on the left, one on the right. So when we did these, we wrote down the rule, when there's one square root sign, you put it on its own at one side or the other. When there's two square root signs, you put one at each side, and you never have any more than that, because you'll be there until the cows come home trying to solve it. Okay? So if there's two square root signs, one on each side, and square both sides, and if there's one square root sign, just get it on its own at one side and then square both sides. Is that alright? And if there's two square root signs, you're going to end up squaring twice. But if there's only one square root sign, you'll only have to square once, right? But you'll figure that out as you're going along. Right, okay, so that was number 8. Right, number 9. Am I doing it? 9? Yeah. Okay. I refused to do the factor theorem yesterday, but I'll give in and do it. Minus 3x squared minus 12x plus 20. So this is the factor theorem, okay? So you have to guess the first factor, okay? So you try and you fill in, if you fill in x is 1, Does it work? Okay, do you end up with naught? So 2 times 1 to be cubed minus 3 times 1 to be squared minus 12 times 1 plus 20, and when you work all that out, you'll get 2 minus 3 is minus 1 minus 13, plus you'll get 7. Yeah? So 1 is not an answer, right? How do you know it's not an answer? Because if it was an answer, you get 0, right? So then you try x is equal to, will minus 1 work? Okay? So it's not minus 1, so you fill in minus 1, right? Okay, and when you fill in minus 1, just for completeness, sorry, that's a cubed, so that would be minus 2, minus 3 is minus 5, I think you get 3, right? Now these answers could be wrong, but you get the idea, it's not 0 anyway, right? So then you try x is 2, so you go 2 times 2 to be cubed, does 2 work? 2 works, does it? Great. Right, okay, so into the calculator with that, okay, and you get 0, so 2 is a solution. 2 is a solution, are we all okay with that? 2 is a solution, but if it didn't work, what would you try next? Minus 2, and if minus 2 doesn't work, what would you try? 3, and then you would try minus 3, right, and then you would go 4 and minus 4 or whatever, and yeah, if you've got to 5, chances are you've made a mistake somewhere, right, okay? So if x equals 2 is a solution, that means x minus 2 is a factor. Okay, so then you do your division. I do my box.
If it was x plus 2 factor, so it would have been x minus 2 then.
Yeah. If it's x equals 2 works, x minus 2 is a factor, because you know the way x equals 2, that was originally x minus 2 equals 0. So that means this is the factor. Is that right? Okay, so 2x cubed, do your division whichever way you do it, plus 20, and I'm going to divide by x minus 2. That would be 2x squared. That would be minus 10. Okay, this would be minus 4x squared. This would be x squared. That's x, checking answers, that's minus 10x, that would be minus 2x, yeah, I'm good. Okay, so when I divide, my quadratic is 2x squared plus x minus 10. Solving, so you get 2x and x, 2 and 5, plus and a minus. Then you let each bracket equal 0, and you get x is equal to minus 5 over 2. When you let this bracket equal to 0, you get x equals 2. And don't forget, you have an x equals 2 from above also. Right, but you don't have to write it again because it happens to be the same answer. Right? Okay, are we good with that? Okay, factor theorem. You guess the first root. Okay, trial and error. You're not really guessing, it's trial and error it's called. Right, you see if it works. Once you have a factor, you divide and solve the resulting quadratic. Yes?
Would you be right if you did the minus equal that?
Say that again?
Would you be right if you did the minus equal that after the long division?
Yeah, you can do the minus b formula after the long division to solve that. Yes?
If you just have a cubic term in like a thing, would you just be able to use the factor theorem for it?
Yeah, that's how you solve cubic equations. It's the only way we know to solve cubic equations is the factor theorem. Yeah, right? Okay, are we good? Right, how am I going for time? I still have 5 minutes. Yay, I'm doing great. Right, okay. Now, I'm going to do number 10 before I even ask you, because I know there's a bit in it that we wouldn't have seen. Okay, right, so number 10 is f of x is equal to 4 times x plus 1 or to the power of 3 times x minus 1 to be squared times 2x minus 5. Okay, if I was to square this out, right, if I was to square this out, right? Or multiply it out, not to square it out, right? If I was to multiply out all these, right, what would I end up with as my highest power of x? X to the power of 6, because here it would be x to the power of 3, wouldn't it? Here it would be x to the power of 2, wouldn't it? Right, and here it would be x. Agreed? So, x to the power of 3 multiplied by x to the power of 2 multiplied by x to the power of 1, would it be 7?
Because you're not adding it.
Sorry, I'm after confusing myself.
So it would be to the power of 6.
It would be to the power of 6. Yeah, x to the power of 3 multiplied by x to the power of 2 is x to the power of 5 multiplied by x is x to the power of 6. Right, your highest power of x there would be x to the power of 6. Would you agree?
Yes.
Right, okay, so when you multiply out that, now I haven't the notion of multiplying it out. I'll be here until Friday week, right, okay? Midterm will be over by the time I have that multiplied out, okay? Right, so I ain't multiplying it out, but I'm just saying, if I just multiply out the x terms, right, I'm going to end up with x to the power of 6, right? So,
Wait, so miss, when you're multiplying powers, you're adding them.
yeah, you're adding them.
Oh.
Yeah, right, okay? So if it's x to the power of 6, how many answers do I have? If it's x to the power of 6, I'm going, no. If it's x to the power of 6, how many answers do I have? When it's x squared, how many answers do you get? 2. When it was x cubed, how many answers did you get? 3. If it's x to the power of 6, how many answers are you going to get? 6. So you let each bracket equal naught. So you know the way x is equal to minus 1, but that's going to be there 3 times. So x is equal to minus 1 is 3 answers, right? This one here, x minus 1, what's the story with that? X equals 1, and it's there twice, isn't it? Right, and the final one, 2x minus 5 equals 0, so that means x is equal to 5 over 2. Okay, 1, 2, 3, 4, 5, 6. Right? Got it? They're my 6 answers. Right? What if I was drawing a graph, what do these answers, what relevance have the answers? It's where it
It hits the x-axis.
where it hits the x-axis. Yes.
The first one, like the first 3 are plus.
Are they?
Yeah.
No. Yeah. No. Yeah, but you let x plus 1 equal naught, so that means x equals minus 1. Sorry? Oh, don't worry about multiplying it by 4. Don't worry about the 4 at the start. 4 at the start doesn't matter. Right? Okay? So this is an x to the power of 6 graph. When we studied about drawing graphs, x to the power of 6, what's the story with the ends? Will they end up pointing in different directions, or will they end up pointing the same direction? They'll end up pointing the same direction, won't they? Right, okay. So they'll end up pointing the same direction, right? And if it's, what else do I need to say? They're going to end up pointing the same direction. Okay, so we know, so they'll both be pointing up. Why would they both be pointing up? Because it's what? The x to the power of 6. Is the x to the power of 6 going to be, is that, when you multiply out the x to the power of 6, is it going to be a positive number or a negative number? It's going to be a positive number. If it's a positive number, it ends on a high. Right, okay, but we already said that where they start and end the same. So if it ends on a high, what does it do? It starts on a high, doesn't it? So we've established it starts on a high, it finishes on a high. And it ends on a high because x to the power of 6 term is positive. Right, so it's x to the power of 6, it's positive. So because it's x to the power of an even number, that means it starts and finishes on pointing the same direction. right? If that was x to the power 5, one, where it starts and where it finishes would be opposite, wouldn't they? Right? So we've already established yesterday that if it's an even, the start and the end point in the same direction, right? X to the power 6 is a positive number, so there's no negatives there. Just give me a minute. X to the power 6, there's no negatives, right? Okay, so it'll be a positive number, so that means it'll be the same. Right, okay, I'll come back to this question tomorrow and talk more about it. Right, homework tonight is you pick questions, you come with the questions tomorrow. We have a test on this chapter on Thursday, right, okay? You revise tonight yourself and you bring me the questions to do tomorrow, okay?